Hi, everybody. It's Miss K back at it again for another science lesson. So for today's science lesson, we are actually going to be continuing on to lesson 9 of our weather textbook. And it is the big question that we want to answer today is oceans do affect the climate. So we want to figure out how that is possible. How do oceans affect climate and weather? Okay, that's the big picture about what we're learning today. I wanted to kind of share, if we were in school like normal, I wanted to share what our lesson would look like. Because as we're all kind of, learning virtually, we have to change things and teachers have to change their lessons around. But I really liked this lesson if we were in school. Unfortunately, we can't do it, so I'm a little sad about that. But basically, it's like a reader's theater type of lesson. And if you've never heard of a reader's theater, let me tell you what that is. But wait, what it is basically teachers will have, it can be in any subject, anything. What it is teachers basically have a play, a play like when you go to a musical or a school play, and everyone has lines they have to say. You basically are putting on a play in your classroom. And as you can see in this picture, we would be dressing up and really getting into our characters. And some of the class would be able to be the actors and actresses. And some of the class would be the audience and would be able to listen and learn to what they had to say. So this is one of my favorite types of lessons. And I'm just so sad that we aren't able to do it this year in this type of way. But I wanted to show you. It's pretty cool lesson. Then I had to think about how I wanted to teach this virtually. Since it is several pages long of the script of the actors talking about this, I just thought it would be too long for me to sit here and read 6 pages of a play by myself. I would say I'm pretty entertaining and fun, but it just would be too much, and I don't want to lose anybody, and I don't want anyone to fall asleep on their computer. That would be not good. So what I did is I kind of read all of this. I found a very short YouTube video, and I found my globe bigger than my head. It's a big old globe bigger than my head. And I'm going to kind of break down this lesson for you so you can take away the most important part of this video without it being 20 minutes of you watching me read a play by myself, because sounds very sad and lonely for all of us. So let's get started, okay? What I'm going to do, so you've seen what this lesson looks like, and you've seen that I'm going to do it a little differently to make it basically short and sweet. I have heard your message. You guys like play posits, and you guys like them as short as possible. So we are going to do this together. Oh, my computer's frozen. Not great. Let's see here. Computer is frozen. Okay, there we go. Oh boy, hold on. Okay, we'll just let my computer do its thing. I'll stop sharing. Okay, so we're gonna do a little jump into the lesson now, a little refresh your memory, and then we will go on to our new part of our lesson. So this is kind of gonna be a review. It's always good to hear things twice. Okay, so the past few lessons have been about, of course, different types of weather and climate, okay? We know that climate is weather that is tracked and doesn't change over a long period of time, usually between 30 to 50 years is how we can track climate. Here on our globe, I want to point out a few things. So let's do one thing at a time here. I want to put this so you can all see it. Maybe I will be fancy and I will flip my camera. That might be better. It's a lovely classroom. Okay, let's see. Try this out. Bear with me here, folks. Apparently it's very dark looking, but that's okay. Okay. All right, so this is a globe. You will see it in classrooms, especially in mine, and I'm going to use it today for my lesson. So key points, I said we're going to do some reviewing first, okay? As you can see, this is a globe of the entire world, okay? On this globe, we have oceans, we have continents, okay? Things that you have learned about in social studies and things you have learned about in science. Then I'm going to post a question now. What is this imaginary line directly in the middle of Earth? Great. I really, really hope everyone said that this was the equator. The equator. That was what we learned about on Monday. And that, please make sure you do that. Play pause it before you do this one. Just always remember to do, if you are behind on science, do the oldest assignments first to the newest one. Okay. So, yes, we have our equator, okay? And what we learned on Monday, we learned a bunch of things, but what we learned on Monday is that the equator is, we learned why. We learned that we all know that the equator is filled with warm climates and a lot of tropical climates, very warm, very hot. We learned that the closer you are to the equator, the closer the land is, and the closer the water. I'm sorry, not closer. Yeah, well, the closer the land is, it's warmer, and the closer the water is to the equator is warmer, okay? So this, let's see if I can do this. This band right here, I'm going to spin the globe. Right here's Asia. We talked a lot about Asia too. So this band right here where my hand is, right here, look, now I'm going over Africa. This band here, oceans and land included. This is going to be the warmest climate and the warmest water found, okay? And let's go back here. The video of that man from Monday was a video, I really liked it. I hope you did too. But the man was in Peru, which is going to be in this general region here, right in South America, okay? And you can see the equator cuts right here on South America. So that was pretty cool to see. It was a great snippet to see the warm weather we saw. We saw how many species and animals live and thrive in that kind of climate because it's so warm. So we were able to see a lot about that too. But where was I going? I just wanted to point out that this band is where the warmest temperatures are going to be. And as you get farther and farther away, it's where it gets even colder and colder and colder. And we learned why. Okay, let me flip this around so you can see me. Now I'm going to ask a question from in relation to that. Why is it so much warmer over the equator and around the equator? Why is it so much warmer around the equator? Answer that question now. Great. So the reason being, this is also from Monday. So really, if you haven't done Monday, do it because you will learn a lot. Okay, so the reason that it is so much warmer by the equator is because of the sun. The sun is directly over the equator. So we see that the equator is in the middle of Earth. But the reason why the equator is so warm the way it is because the sun is always directly above the equator. Answer that question now. The sun is blank above the equator. The sun is directly above the equator, okay? And that's why it is always so warm. Right here you can see, okay? The sun is directly above. Now, This doesn't mean that a place that's always very cold, like Antarctica, doesn't get any sun. You know that's not true. Polar bears see sun, glaciers, you see sun, okay? Sun is everywhere. It doesn't mean that it's not up here and down here. It just gets much less sunlight. They do not see as much sunlight as somebody that might live in Peru, okay? Also, we know that the sunlight reflects off of ice and off of glaciers and off of water. So that's why it's so much colder there. So the ice reflecting off and the sun being so far away is why it's so much colder in areas such as Antarctica, okay? That's something important to keep in mind. And you'll probably hear me say it again because it's just important to know, okay? So these, trying to think if there's anything else I want to point out. That is like a big chunk of the last few lessons. That's like the biggest points that I want to keep with you if you have taken anything away from science, are those main points. Now today we're going to talk about oceans again. So we have talked about ocean temperatures. Let me refresh your memory. Share my screen. So I did show you this photo, okay, and I asked you, how are these different and how are these similar? As you can see above, everyone can see. Some people got this wrong in their play posits, but you can still see the sun in this. This looks like it might be Antarctica, somewhere very, very chilly, okay? Maybe there's some polar bears in this area. It might be a good guess. However, I asked you to compare and tell me the similarities and differences of these photos, because at first you're like, they aren't similar at all, but they are both oceans. They are both, you can tell in this picture from the lighting that they both are, it's the daytime, they see the sun. However, the way that they absorb the sun is very different, okay? And I like this picture because it kind of shows that, because we wouldn't think normally that these pictures have anything in common. However, that's something that we learned. So going forward to this lesson, okay, we are now in lesson 9. We are going to learn the biggest question that we would need to ask is, how do oceans affect the climate? Okay, so from that sentence alone, you learned something. Oceans affect the climate. I'm going to put in a true or false here. Do oceans affect climate? They do. They really, really do. So basically, that's what this lesson is all about. How do oceans affect climate? So we know the warmer water is going to be towards the middle of the earth where the equator is. And the farther away, the colder the climate is and the colder the weather is. So with that, there's some construction going on across the hall for me. So I'm a little distracted and wondering what they're doing. But anyway, so we want to learn today, how is that possible? How do oceans affect the climate? Because if you think about it, I'm sure this would be kind of a discussion we would have together. But oceans, let's see if this is working. Yeah. Oceans have, different water temperatures. Yes, it's true that the oceans reflect sunlight. We've talked about that. Water reflects sunlight. However, it still absorbs some sunlight, okay? And heating and cooling still happens, just like, think about a summer day. If you had a pool, like an inflatable pool of water, you just bought an inflatable pool from Walmart, you're blowing it up, and you put hose water in it. It's going to be very cold at first. Like that hose water, when you jump in that pool, it's gonna be really, really cold. if you have that water sitting out for a long period of time in an 80-degree day, it is going to get warmer over time. It will not take 5 to 10 minutes. It'll take a few hours, but the water eventually gets warm. So the more sunlight that the water sees, the more closer the sun is directly over the water, the more warm the water is going to get. So oceans still get water. Oceans still get sunlight, okay, is an important thing to learn in this lesson. And just think of like the rivers and lakes you see here in Allegheny, there is currents. Oceans have large currents too. And the currents is what takes the different temperatures of the water and moves them over place to place. I think now will be a good time for me to explain our one new vocabulary word this lesson, and it is currents. So let me read this part of the play. All around the world, there are regular movements of large amounts of ocean water called currents. Some of these currents move warm water from one place to another, while other currents move cool water. And this is kind of a nice photo that kind of shows that, okay? So down here is where we're getting towards the equator. However, because of the currents, it looks, if you're looking at this current, we can see, remember here's the United States, here's North America. This is, I'm kind of pointing towards the middle of North America and South America. And we can see that the red stream is going up and pointing up and going through, and it's taking a turn. You can go to any river and stream and kind of see what a current looks like, but it's not still water, it is moving water. And in the ocean, that's a huge way about how the cooling of oceans takes place. Just think about what would happen if a huge a huge current of water went to Antarctica and was so warm that it melted a glacier. That's kind of how oceans change the climate, okay? So it's basically because of the currents, okay? If you take one thing away from this lesson, I want you to take away these two things. I want you to take away that oceans do affect climate, and oceans affect climate because of these currents and these pockets of hot water and warm water and cool water, and they travel, okay? Those are the two most important parts of this lesson, all right? So I want to keep it short and sweet for you. I want you to just take away those two notes. I'm going to have you bring that up in your Science Wow statement at the end, but I do have a short video that I want you to watch that kind of explains just what I mentioned, okay? So this starts off, it says, how do oceans affect the climate? Perfect video for us, isn't it? And then it says here, in what way does the Southern Ocean influence climate? So let's check this out, okay?
So the ocean affects climate by storing and transporting huge amounts of heat and carbon dioxide. And so if we want to understand how climate's going to evolve in the future, we need to know what's happening in the oceans. About 90% of the extra heat energy that's been stored by the Earth system over the last 50 years is in the ocean. So when we talk about global warming, we're really talking about ocean warming in a real sense.
I'm curious if any of you have heard about global warming. That is a pretty common term that you hear these days. And it's pretty fascinating that we can study global warming by studying the oceans.
So one of the main goals of our work in the Southern Ocean is to measure exactly that. How is the ocean changing? And to learn how ocean changes might affect things like climate, sea level rise, and biological productivity. The Southern Ocean is a really important part.
Now this is more advanced learning about all the different things, but just take this in, kind of just like that textbook. The arrows pointing in the direction that they're traveling is where that water is going, okay? And as you can see from this photo, the ocean, there's a lot of oceans and there's a lot of different directions that these ocean currents new word, currents are taking. Okay, so let's check it out.
Of the ocean to study, because it's really unique in a number of ways. First of all, it's only in the Southern Ocean that there's a band of ocean that circles around Antarctica that's totally unbroken by land. It's a continuous channel of water. And it turns out that the dynamics of the ocean currents that circulate in that channel are very different from the rest of the globe. It's the home to the world's largest ocean current. It carries about 150 million cubic meters of water every second from west to east, south of Australia, between Australia and Antarctica. And that connection between the ocean basins that's formed by that current transforms the whole global pattern of ocean circulation, and also affects global climate, not just the climate of the Southern Ocean region. That strong current, one of the things it does is.
So I want to ask a question in some way with these words. Compare the ocean currents. How do you think they're different from the current around where he just showed Antarctica, and what you think the current would be like, the ocean current temperature would be like in Peru, where our video was on Monday?
Prevent heat from spreading from the relatively warm northern latitudes further south. And so it helps contribute to the icy glacial climate that Antarctica experiences today. It also has a big impact on Australian climate.
So there you go. A few seconds ago, he talked about that in Antarctica, because it's kind of, on its own solo, the current of the ocean just circles around Antarctica like a big old circle. And think about how chilly Antarctica is. So think about if that water is constantly just going around Antarctica, then that water is probably incredibly cold. And it's probably very different than the water that's going to be in between, for example, South America and North America. That's going to be definitely warmer. So that's kind of where I wanted you to go with that question I just asked.
Because it affects the weather systems that come across the continent from the south. So our weather in Australia is largely determined by what happens in the ocean.
And again, the red arrows are the warm water moving, and then the blue arrows are the cold water moving.
Oceans around us, either the Pacific, the Indian, and the Southern Ocean for the southern part of the continent. Another thing that makes the Southern Ocean very different from the rest of the ocean is that it's one of the few places, or the only place, where water that's at depth in the ocean, 3,000 or 4,000 meters below the surface in most of the ocean, rises all the way to the sea surface in the Southern Ocean. And so it's the only place where the atmosphere connects to the deep ocean, and that has a lot to do with how much CO2 remains in the atmosphere.
All right, we are just going to watch that one video. So I'm going to ask you a few final questions about points that I have.
Good grammar and spelling are important, but if you want to write essay.
So much going on. Okay, so I'm going to reiterate a few questions that I have answered today, and I hope that you take away those two important points. Point number one, I want you to take away: oceans affect the climate. Point number two, I want you to take away: how do oceans affect climate? Because of the currents of the ocean's water. Okay, there is a warm current and there is a cold current of water, and that travels, which spreads the heat and the cold to different places. Okay, and over long periods of time, that is going to affect climate. Okay, so I hope you enjoyed this lesson. I'm glad that you got to see me today. I won't be able to see all of you today, but just know I'm thinking about you all. Please feel free to message me. Ask me any questions. I want to hear from all of you, and I'm always thinking about you guys. Have a good rest of your day.